Allison Transmission is a leading designer and manufacturer of vehicle propulsion solutions for commercial and defense vehicles, the largest manufacturer of medium and heavy-duty fully automatic transmissions, and a leader in electrified propulsion solutions. Allison on- and off-highway transmissions are implemented in a wide variety of vocations around the world. In this video, we will discuss the principles of operation that keep Allison fully automatic transmissions running smoothly and reliably. Understanding the fundamentals of a transmission will help you decide which transmission will work best for you and your job. First, let's take a look at the role of a transmission and how features such as our patented torque converter set us apart from manual and automated manual transmissions.
The transmission's primary role is to convert the engine's rotational power into a wide range of output speeds. The transmission is located behind the engine. The engine crankshaft connects to and drives the transmission input. The transmission develops output rotation, which is typically supplied to the vehicle's final drive, or axle, by a drive shaft or drive line. Without a transmission, the vehicle would be limited to a single gear ratio, making the vehicle very inflexible. Modern vehicles require the ability to accelerate from a stop, handle a load, and attain normal road speeds. A single gear ratio typically provides either good low-speed performance or good high-speed performance, not both. Manual transmissions typically rely on the operator physically moving gears, using a manual shift selector to manually select transmission ranges. In a basic manual transmission, gear ratios are based on the number of teeth on two gears, the drive gear and the driven gear. When the operator manually shifts the transmission, the drive to driven gear tooth count changes and various ratios are created. A clutch is typically required to disconnect and engage engine power to the transmission. Disengaging the clutch, foot pushing the clutch pedal, removes the engine power from the transmission. This allows the operator to make manual shifts and allows the engine to idle with the vehicle stopped and the transmission in range. Engaging the clutch, foot off the clutch pedal, mechanically connects the engine and transmission input. The power from the engine can be used by the transmission to create output when a moving range has been selected. Allison automatic transmissions upshift and downshift automatically and don't require an operator-controlled clutch. The Allison torque converter connects the engine to the transmission input. At a stop, engine power is not transferred through the torque converter to the transmission input. When the engine RPM increases, the torque converter drives the transmission input. The transmission electronic control and hydraulic systems work together to automatically control shifts.
Now, let's take a look at Allison's planetary gear sets.
Allison transmissions are constructed with planetary gear sets. Planetary gear sets consist of a ring gear, sun gear, and a carrier assembly which includes pinion gears. Various output ratios are created by holding and driving components. To decrease input speed and increase torque, the ring gear is held, the sun gear is driven, and the carrier becomes the output mechanism. To increase input speed and decrease torque, the ring gear is held, the carrier is driven, and the sun gear becomes the output mechanism. A 1-to-1 ratio is achieved when no components are held and two components are driven at the same speed. Reverse is created by holding the carrier and driving either the sun gear or the ring gear. Most 1000, 2000, 3000, 4000 transmissions utilize 3 planetary gear sets. The gear sets work together to create the necessary output ranges, often using created output from one gear set to drive components in other gear sets.
Along with the planetary gears, Allison uses a specific set of stationary and rotating clutches. Let's take a look at how they work.
Clutches are used to hold, connect, and sometimes drive planetary components. Allison transmission clutch assemblies are multi-disc, consisting of an alternating stack of fiber, friction, and steel reaction plates. Clutches are applied by compressing the plates together using a piston forced by hydraulic pressure. Clutches are released by spring pressure when the hydraulic pressure against the piston is exhausted. Stationary clutches hold planetary components or shafts. Rotating clutches lock rotating components or shafts together. Most 1000, 2000, 3000, 4000 transmission gear packs utilize 3 stationary clutches and 2 rotating clutches.
Next, we will see how range shifts and the systems behind them operate.
Clutches are applied in various combinations to create different output ranges. The transmission, electronic control, and hydraulic systems work together to apply and release clutches. The electronic control monitors and adapts shifts to match driving conditions. The electronic control also monitors inputs from vehicle systems to enable optional operational features. For example, if programmed, the electronic control may prevent shifts out of neutral unless a signal is received indicating the operator has depressed the brake pedal. A variety of optional features are available depending on the transmission configuration and intended use, also referred to as the vocational model.
This next video will show how Allison's electronic controls and transmission control module, or TCM, function.
Allison electronic controls work with the hydraulic system to control and continually refine shifts. The transmission control module, or TCM, is an onboard computer connected to other electronic control components and the vehicle by wiring harnesses. The wiring harnesses offer J1939 and diagnostic tool interface and enable connection to other vehicle systems using analog wires. The TCM electronically controls solenoids located in the control valve body to determine when and how shifts occur. Key factors affecting shift control include engine speed, transmission turbine speed, transmission output shaft speed, and the amount of throttle being requested, throttle position. Based on these and other inputs, the TCM energizes and de-energizes solenoids. Solenoids direct fluid flow throughout the transmission to position valves, apply clutches, and provide cooling and lubrication.
When looking for an Allison that is right for you, the Vocational Model Guide might help you find your vocation and the models within. Here's how.
Allison uses vocational model designations to specify how transmissions are used and which optional components and programming features are available. For example, the HS, or Highway Series, vocational model is specific to vehicles which will only be operated in on-road conditions, not used off-road. The HS vocational model includes 1000, 2000, 3000, and 4000 transmissions to satisfy a variety of vehicle and engine sizes. Electronic programming features and options are grouped into logical packages for the various on-highway applications, and external feature availability is matched to the vehicle's intended use. For example, RDS transmissions are available with power takeoff, or PTO, provisions because applications utilizing these transmissions typically require a PTO to power various vehicle features. Allison Tech data, available online for Allison service channel partners, including authorized distributors, distributor branches, and dealers, maintains the very latest product information, including transmission specifications, vocational model information, and much more. The latest version of the Vocational Model Guide, available through the Allison Transmission Publications website, is another resource that compiles vocational model, specification, and input-output package information.
Allison's additional features may help your fleet perform the job better. Here, for example, is Allison's retarder.
3000, 4000 product families retarder. The Allison Output Retarder is available as an optional feature for most 3000 and 4000 product family transmissions. Retarders assist the vehicle braking system, extend service brake life, and improve braking control. The retarder rotor is physically connected to the transmission output shaft. When the retarder is applied, The retarder housing is charged with transmission fluid, which slows the vaned rotor. The initial charge of fluid is provided by an externally mounted accumulator. When the retarder is turned off, the fluid in the retarder housing is evacuated, and the retarder no longer slows the transmission output. Retarder application increases transmission fluid temperature, and the vehicle cooling system must be designed to dissipate this heat. Allison offers transmission fluid coolers specifically designed to aid the cooling system when vehicles utilize retarder-equipped transmissions. Various retarder capabilities and control systems are available. Retarder capacity is an indication of the retarder's slowing capability and is determined by electronic controls programming. An enable-disable switch is required for all retarder-equipped installations. Additional operator controls may or may not be included, depending on the configuration.
Thank you for reviewing the principles of operation within Allison fully automatic transmissions. If you would still like more information or help finding the right transmission for you or your customer, contact your local Allison representative or visit AllisonTransmission.com to learn more.